Welcome to this explainer. Today, we're jumping straight into the cockpit of the Bombardier Q400 to master two absolutely critical standard operating procedures. We're going to break down the highly efficient single-engine Taxion, and then we'll tackle the rapid-fire touch-and-go training circuit. So, if you've ever wondered exactly how pilots maximize efficiency on the ground, or, how they drill those precision maneuvers in the air without wasting a single second, well, you're definitely in the right place. Let's get to it. Okay, let's look at the agenda for our sequential Q400 walkthrough. We'll be covering single-engine taxi rules, when to avoid it, engine 1 shutdown steps, handling taxiing failures, touch-and-go landings, and finally, aborting a touch-and-go. Starting right off with Section 1, single-engine taxi rules, mastering efficiency on the ground. So, to really simplify the engine dynamics of the post-landing taxi in the Q400, I want you to think of engine number 2 as our worker bee. It's the engine that stays operating to do all the heavy lifting. Engine number 1, that's the resting bee. It gets placed in start and feather, or it's just shut down completely. But before the pilot in command even attempts this maneuver on a hard surface, they absolutely must verify safe conditions using a very specific mental checklist. We call it the 2800 dry rule. The first part of that memory rule is 20. Basically, the taxiway width must be equal to or greater than 20 meters. Without that clearance, the asymmetrical thrust of using just one engine makes maneuvering way too risky in tight spaces. You literally need that 20-meter buffer for safety. Next up, the second part of the rule is 800. Visibility has to be greater than or equal to 800 meters. You need to clearly see exactly where you're going. And finally, dry means exactly what you think it means. The taxiway and ramp surfaces cannot be wet. Why? It's all to avoid nose tire skidding. If the ground is slick, pushing off with just the right engine could literally push the nose wheel right out from under you. No way we want that. Now, once those specific conditions are met, the actual physical handling of the aircraft changes pretty dramatically. You will literally feel the need for forward momentum, especially for turns into the operating engine. Because engine 2 is over on the right wing, making a right turn means you actually have to carry a bit of speed into that turn. You've also got to anticipate your turn radius and watch out for varying taxiway slopes so you don't have to make massive sudden power changes. And, this is absolutely crucial, if you do have to apply power above flight idle, you must remain hyper-aware of your propeller slipstream. That blast of air is powerful, and you've got to watch out for ground personnel and surrounding objects. Moving on to Section 2, when to avoid it, the do not fly checklist. So the pilot in command always has ultimate authority. They can discontinue a single-engine taxi at any time, restart engine 1, usually checking with engineers first, or just simply call a tow truck. But outside of pilot discretion, there is a strict, non-negotiable, do not fly checklist. If your nose wheel steering is out, if there is literally any hydraulic system failure, if you had to use the alternate landing gear extension, or if either the number 2 DC or AC generators are inoperative, you do not attempt this maneuver, period. Also, a quick tip. You cannot invert the process, meaning you can't try to keep engine 1 operating while shutting down engine 2. It absolutely must be engine 2 that stays operating. Let's hit Section 3, Engine 1 shutdown steps, precision in the cockpit. Okay, so assuming the weather is good, the taxiway is wide, and all systems are healthy, how do we actually execute this? Well, once you're fully clear of the active runway and the after-landing flows are complete, it's time to shut down that resting bee. The most critical memory trigger here is 30. You must allow a minimum of 30 seconds for engine number 1 to thermally stabilize after moving the condition lever to start and feather. Then, and only then, can you proceed to final shutdown. The exact chronological flow you need to memorize goes like this. Ready? First, power lever number 1 goes to disk. Second, condition lever 1 moves to start and feather. Now, this is exactly where your 30-second clock starts ticking. While you're waiting, step 3, accomplish your after-landing checklist. Step 4, turn bleed number 1 off. Step 5, condition lever 1 goes to fuel off. Now, boom, you are taxiing purely on engine 2. Finally, step 6, just double-check that your standby hydraulic pressure and PTU control are on, making sure your hydraulic pressures and quantities remain within normal limits using that engine 2. Right into Section 4, handling taxiing failures, action and reaction in emergencies. Now, even when you've done everything perfectly by the book, what happens if you encounter sudden system losses? Because we're operating with reduced redundancy, the impacts are immediate. If you lose number 1 hydraulic system pressure, your normal braking will be lost. But if your worker bee, the number 2 engine, suddenly fails, this situation compounds. Think about it. You've already shut down engine 1, so losing engine 2 strips away both your normal braking and your nose steering at the exact same time. You're suddenly rolling along without brakes or steering. So the absolutely crucial point here is that if either of these failure scenarios happens, your immediate and literally your only reaction is to apply the emergency brake to halt the aircraft safely. You don't sit there trying to troubleshoot while you're rolling. You definitely don't try to restart an engine while drifting off the center line. No, you hit that emergency brake, bring the Q400 to a complete stop, and then you manage the problem. So, having mastered efficiency on the ground, we now transition to the air. How exactly do pilots build the muscle memory required for these incredibly precise procedures? Let's look at how strict disciplines are honed during base training, where every single second counts. Section 5. Touch-and-go landings. The training circuit? Now, touch-and-go landings are used exclusively for approach and landing practice during base training. Honestly, it's a super fast-paced environment requiring this highly coordinated, split-second choreography between the trainee flying the plane and the instructor managing the configuration. To make memorizing the flap configurations completely effortless, just use this simple trick, the rhyme. 15 down, 10 to go. It's brilliant. The trainee executes a normal final approach and lands with flaps 15. And the very split second the main wheels touch down, the instructor immediately sets flaps 10 for the go-around. 15 to come down, 10 to go back up. The exact sequence maps out the precise pacing perfectly. At touchdown, power goes to flight idle and the nose wheel is lowered. The instructor then selects flaps 10 and ensures the ground spoilers are down. Next, the instructor calls go around and smoothly advances the power levers. At VREF speed, the instructor calls rotate and the trainee smoothly pitches up to 6 degrees. Then it's landing gear up, and the instructor sets the heading and altitude select. But pay special attention to this critical sensory cue. The instructor must adjust the pitch tram within the takeoff range before setting takeoff power. If they forget, you are going to be blasted by a screaming takeoff warning horn the moment those levers advance. And our final section, Section 6, Aborting Touch and Go, the ultimate absolute rules. Okay, even in a highly controlled training environment, emergencies happen, right? A bird strike, a sudden system failure, maybe a runway incursion. The procedures for rejecting a touch and go rely on immediate, absolute rules. If an abort is necessary, the instructor's action is decisive. They forcefully call abort, simultaneously take physical control of the aircraft, and apply maximum braking and reverse power. And keep this vital fact in mind, there is no V1 decision speed on a touch and go. It's entirely based on the instructor's immediate split-second judgment. I want you to treat this warning as absolute law in the cockpit. After reverse power is initiated, a full stop landing must be made. Once those reverse thrusters deploy to slow you down, there is no changing your mind. Actually, scratch that, there is literally no turning back into the air at all. The aircraft is 100% committed to stopping on that runway, no matter what the situation is. Furthermore, there are a couple of other scenarios where a full stop is deeply enforced. For instance, if you land with flaps 35 instead of the standard 15, a full stop landing is heavily recommended. Also, if the instructor decides to discontinue after takeoff power has been applied, they only do so if they are absolutely certain the Q400 cannot safely fly. Because once that power is in, the safest place is usually up in the sky. So, what does this all mean? Reflect for a moment on how internalizing these procedures really changes your mental model as a pilot. Understanding the worker bee dynamics of the single-engine taxi and getting that 15 down, 10 to go rhythm perfectly locked in, it all builds this incredible foundation for total cockpit mastery. When you memorize the flow, you free up your brain to handle the unexpected. So I leave you with this. What other standard operating procedures can you break down into simple mental triggers to elevate your own expertise? Thanks for joining me on this explainer. Keep learning and fly safe.